So don't guess monitor. What you can see here is this is a screenshot from the company that we use that makes our monitors, OmniSense. OmniSense makes these monitors. The ones I showed you guys a minute ago that do temperature, humidity, as well as wood moisture content are going to cost you about $40 to $50 a piece, and they're going to spit out data like you see here on this graph that you can check at any time. You know, it's terrible. I should probably get a better hobby, but I find myself sitting on the couch at night seeing what the relative humidity is inside of my wall assemblies at certain times of the year. But you now have access to that. If you put these in, you have access. So the way that the system works is we have these monitors and we bury them in key locations throughout the assembly. Generally, we'll put them in a roof assembly, a north-facing wall, a south-facing wall, and then one on the inside of the building. And what that allows us to do is that allows us to watch what's happening temperature-wise and humidity-wise inside of the building. That allows us to, control the indoor environment for comfort and air quality for the client. It allows us to correlate anything that we're seeing happening inside of the wall to anything that's happening inside of the building. Maybe the client shut the ERV off, or they've, moved a 200-gallon fish tank into the building, and we see a spike in humidity, and then we see a corresponding spike in our wall assembly. And we get to see all of that in real time whenever we want. So we have here, this is a basic sensor. Like I said, these are the S11s. These are the most common ones that we use. These get embedded anywhere you want inside of the building. Like I said, they're about $40 or $50. They have a battery inside of them, a lithium-ion battery that will last anywhere from 5 to 40 years, depending on their sample rate and, temperature conditions and stuff like that. So we're able at, worst case scenario, we're going to gather 5 years of data off of this. And what they do is they communicate via that little antenna to this thing. It looks like a little wireless router. So the only visible part of this mechanism that our client sees or has to live with is this little wireless router that we leave in the house, and we just instruct them, keep it plugged into power and keep it, connected to Wi-Fi, or often I'll set it up with an Ethernet cable directly to their modem. And that's all that they see. And what that will then do is that it'll spit out information like this for us. So what we can do is we can plot out our wood moisture contents, we can plot out our relative humidities, we can plot out our temperatures, and we can see how they're doing in different areas of the building. So in this example, you can see that this is a second floor north wall mounted high in the bay, close to the sheathing, about 18 feet off the interior or west gable. I label them so that I know where they are, so that if I ever have any issues or want to go back and for some reason check on the sensor or remove it, I know where it is. Or I can correlate that with looking back at the blueprints of the building to know where it is that it's monitoring. And this will spit out this graph data for us so that we can actually see the conditions. One of the common things that we want to watch for is dew point or condensation in the building. So one of the frequent things that I'll do is I'll go in and I'll plot the dew point and the temperature, and I'll watch and make sure that they never cross each other. As long as those two lines never cross, then we know that we don't have any condensation happening inside of the building. Alternatively, we build some wall assemblies that we'll get into in our breakout session, double stud walls, that for years people have said are doomed to fail because the computer monitors say that they're going to load up with condensation. Well, we've been watching them now for a number of years, and guess what? They don't. We've also had the opportunity to cut some of them open after 10 plus years, and they're perfectly fine. So this is just our due diligence to be able to watch the dynamics of what's happening inside of that wall. So number one, it allows us to, ensure that what we're building is correct. It allows us to diagnose what's going on inside of the building in case there's an issue. And third, it's just great education. There's no other way that you're going to get this information without putting some sort of monitoring in. It really, it's like when you first start blower door testing your buildings. Sure, you get an air changes per hour number, but you start to get a crucial understanding of where that air change is coming from, where those leaks are, how you can prevent them in the future. When you start looking at data like this, it starts giving you, a really ingrained understanding of how the building is actually performing. Computer models will tell you one thing of what the computer thinks it's doing, but in this case, we can actually see what our building's truly doing. So click through some of our data here. This here, oh, there we go, back to that one. What we've done now is, aside from just watching the thermal dynamics, the hydrothermal dynamics of the building, is we've also started to pay attention to the indoor air quality of the building. So there's, obviously with COVID going on, but just in the public awareness, there's a greater interest for people to know what the quality is of the air inside of their building. A good metric for that is to monitor the CO2 usage inside of the building. So we've started, along with the S11 sensors watching, the temperature and the humidity, we've started putting CO2 monitors in our building. Generally, we're going to locate these in a bedroom or close to a bedroom, near a return duct or something like that, because the bedroom is where you're going to see the largest spikes in CO2 in the building, because it's where we spend the greatest amount of time. So we use these to monitor the quality of the air that's going on inside of the building. These are a little bit more expensive than the S11 sensors, but we consider it, due diligence, and it's a good learning experience for us to understand not only how our building as a whole is performing, but also how the HVAC system and the ventilation system is performing. What that then spits out for us is something that looks like this. This shows us our peaks and valleys throughout, 24-hour periods over a course of months of what's actually going on with the CO2 levels in the house, and that allows us to correlate the general health of the indoor environment. So with that, I'll kick it over to Dan and let him toss some thoughts in on this.
I've just been trying to follow the Q&A and answering as they come up. One thing I just want to say quickly is just, there's a monthly service charge with this stuff too, so you be aware of that. But Chris Hugenboom, the owner, is an incredibly approachable and knowledgeable guy, and I really encourage everyone to talk to him. Also, in terms of other equipment, Omnisense is the only ones I know that you can bury them and record the data. But Hobo, on the Onset Corp, who make Hobo meters, they also have a bunch of great stuff that you can use as well. But again, you can't bury it.
Well, Hobo has some meters that you can bury. They're just not, well, maybe recently they've released some new models that you can monitor wirelessly. So you can bury the sensors. The problem with the Hobos is that they were Bluetooth enabled, so you would have to go back into the building and watch them. Right. And actually download the data off of them. These are also great, like if you have a client, a client that's having comfort issues or humidity issues or mold issues inside of their building, you can go in, you can drop some of these sensors in, and you can get a kind of a good look of what's going on before you start trying to affect any sorts of change or adjustment. Justin?
Okay.
Right. I also just want to say quickly, we found we didn't go through the charts very carefully, but we've got an issue in that building that we were showing where we don't think that the insulation in one of the roof assemblies got packed densely enough, the cellulose. So we might not have learned about that till some horrible problem occurred, but now we can deal with it hopefully before anything happens.